Let's try the second set in our nuclear physics chapter. This one here, half-life. Okay, recall that in my class I said that half-life is the time required for the mass of an radioactive element to reach half its original mass. What do I mean by that? For example, assuming you have carbon-14, the half-life is around 5,430 years. Let's assume you have 1 kilogram of carbon-14, 1 kilogram, and you leave it locked in a room. Okay, assuming you live for 5,430 years, when you're 5,430 years later, when you open that same room, that 1 kilogram of carbon-14 should be around 0.5 kilograms, right? And of course, this process keeps continuing. The next 5,430 years, you become 0.25. There should only be 0.25 kilograms left. Okay, it will keep continuing until there's nothing left. Okay, that's how scientists define the half-life of a radioactive element. Okay, knowing this, let's try a question. Question 1. All right, so the question says we have a sample of sodium-24. Sodium is natrium. All right, initially contains 40 million atoms. All right. After 2 days, it doesn't have to be mass, by the way. Half-life doesn't have to be mass. It can be number of atoms, number of counts, and also of course mass, the kg. After 2 days, the number of sodium-24 reduces to 5 million atoms. They want you to estimate the half-life of sodium-24. Now, there are a few ways of doing this type of question. I'm going to show you the easy way first, all right? Then we'll come back and do the more complicated way later. Okay, so first of all, what I'm going to do is, since I have such a big space, why did I give such a big space? All right, draw a big box, all right, to fully utilize. So initially, I'm going to put 40 million. So I'm just leaving it at 40. After 2 days, it has reduced to, I'm going to draw another box here. After 2 days, it has reduced to 5 million. All right, so what I'm going to do is that, remember, half-life means half the mass, not half the time. Okay, remember that, I said that in class. So 5 million. So what I'm going to do is, in order to ask that half-life, what I need to do, I need to divide this 40 into by 2. So I get 20. Okay, and divide this 20 by 2 again, and I get 10. And I divide it by 2 again, and I get 5. All right, so draw an arrow in between each of them. Okay, so 2 days is how many hours? 2 days is 48 hours. So from the initial, this one here, 40 million atoms, to the final one, there were 48 hours. How many arrows do we have? Okay, it's very simple, this method. So count the arrows. So it's 3 arrows. All right, so what I'm going to do is I'm going to divide 48 hours by 3, and I'll get 16 hours. So the half-life of each, the half-life of sodium or natrium is actually 16 hours. You don't believe me, you can try yourself. So it's 16, 16, 16, 48. Okay, let's try question 6 now. So let's read our question. So in question 6, during an expedition into the Pacific Ocean, scientists found an old rock. A test was conducted on the rock and found that the activity of plutonium-239 in the rock is 3.25% of its original activity. If the half-life of plutonium-239 is 24,000 years, how old is the rock? Okay, I'm reading very fast, but you can actually pause or slow down the video. So again, let's use the drawing method. Okay, so first of all right, you have a mass of a plutonium. It's not given, but the mass of anything in the initial stage is obviously always 100%. Okay, and it says that right now, initially we are 100% plutonium. Right now we only are left with 3.125%. The question says that the half-life of plutonium is 24,000 years. Okay, how old is this rock? So what we're going to do is that we're going to divide. Okay, using the box method. Remember, it's just keep dividing the box into half. Okay, what I'm going to do is from 100%, I'm going to divide into half again. 50%, divide into another half again. 25%, another half again, this becomes 12.5%. and half of 12.5% would be 6.25%. And if I divide by another half again, I will get 3.125%. That's the first step, keep dividing the box. Second step, draw the arrows. Okay, remember each arrow is 24, the half-life is 24,000 years, which means each arrow represents 24,000 years. So count number of arrows: 1, 2, 3, 4, 5. 5 times 24,000 years. So how old is the rock? 24,000 years times 5. The rock is 120,000 years. That is how scientists actually they actually tell the age or the date when you watch documentary, how they actually tell how old that rock is, or how old this. That's how they actually tell how old stuff really is.